Good morning, good afternoon, good evening, maybe. Welcome to the HyperFACETS second brown bag, in quotes, for the summer here. We're going to run about an hour. You can see the agenda on the screen. Andy's going to give us a quick update on the project. I've got a couple of cool climate news items to quickly share with you and share the links, and then two presentations from James Eklund and Binod Pokarel. So we have a good hour in front of us. We'll do Q&A, of course, during the presentations. Andy, let me turn it to you for the project update.
Can't hear you, Andy.
Thanks for that.
There you are. Good morning, Andy.
Okay, great. Yeah, so as I was saying to myself, it's nice to see everybody, and I'm glad that we didn't cause any more problems. The first meeting, last two times I've seen many of you was the first week of shelter in place, and then the week that the protest kicked off in the United States. So I think we're doing okay this week. I wanted to welcome some new stakeholders who are joining the project from Utah Department of Water Resources, Candace and Jake. I don't know if you're on the call, but just wanted to acknowledge that we have a couple new folks joining from the Utah Department of Water Resources, and then also from the LA County Flood Control District are joining the project as well. As far as where we're at in the project, we're in a good place with these co-produced research plans that we produced out of the last workshop. So thanks to everybody who has been reviewing and commenting on those. I think they're really nice documents that kind of give us a clear guide for where we're going in the project. And the next step is that, kind of on a case-by-case basis for each of these storylines, we'll be scheduling a working group call to go over some preliminary results and kind of iterate on the research plan to get feedback and kind of more dialogue with the stakeholders and the scientists on each of those. And we're kind of doing that based on each one. We want to do it at a time when there's enough results to discuss, but not too far along that we want to do it at the right time. So that is that's coming. And I also just wanted to mention that the American Geophysical Union meeting, which is the big, typically about 20,000 Earth scientists that get together every year, is being held almost entirely virtual this year. So that's an opportunity for people to participate that might not normally participate. And there are several interesting sessions on actionable science that you may want to either submit abstracts to and actually present something, or tune in and see. And so right now is the time to submit abstracts. And the meeting doesn't happen until December. So those are the updates for me.
Great, thanks, Andy. We have 28 people on the call today, which is great. Great to see you all. Any questions for Andy, though, on the project update?
Yeah, if I can just jump in. This is Bill Gutowski. I put a question in the chat window, but I'll just bring it up here. Andy, could you send us the list of relevant AGU sessions? Because a lot of them come flying by us. We don't necessarily get notifications of all of them. And if you have a list somewhere, that'd be useful to make sure we're aware of all of them and can plan accordingly.
Yeah. So the one, there is something called the Science to Action Network or something like that. That is a group within AGU that kind of organizes several sessions. So that is an easy one where it's already organized, and I can just forward that list of sessions when it's prepared. And there may be a few more we can add to that. So yeah, we can send that around.
That would be great, thanks. And and also maybe we should all be reminding ourselves that the deadline for submitting abstracts is the end of this month, if I remember correctly.
Great. Thanks, Bill. Any other questions for Andy about the project itself?
So this is Kevin. I'm just going to add one additional thing about AGU. Is just a reminder for those of you that are AGU members, there will be an election this fall. And so I would encourage everybody that gets, I'll definitely send an email out when we get there to vote, but yours truly is running to be president of the Science and Society section of AGU. So that's just a heads up to keep your eye out for that.
Are you soliciting campaign donations?
I'm not allowed to a campaign at all. That's why I'm just encouraging you to vote.
That's good. We have 28 right here.
I
Kevin,
have a,
you have to like join that group, right?
Nope. You could actually vote for the offices of any of the sections you want, actually in AGU.
Okay, that's good to know.
So I have a question about, if anybody knows, this is again an AGU question, about what's happening with posters. It seems challenging to have posters in a remote conference. Anybody know?
I think that we will have virtual posters like the e-lightning ones. So there'll just be a different format, but I don't know how many, whether we might be able to do it, but they're thinking about it. Kevin, do you know?
Yeah, I don't know specifically. I'm not on any of the program committees, but I think that they'll operate a lot like, if I had to guess, they'd operate a lot like the e-lightning posters, which are, you kind of populate the information into a service, into a specific website, and then it's available for anybody to kind of go look, and then you can record presentations and stuff like that.
Okay. Any other questions or comments? Great. I have the next item. Each month, we're going to throw out 3 or 4 articles or reports or whatever, and here are the 3 for cool climate news for July. First one, Ayanna Elizabeth Johnson, who's an oceans scientist, runs something called the Ocean Collective. And she's written a piece an op-ed in the Washington Post, "I'm a Black climate scientist, racism derails our efforts to save the planet." And I'll put the link to all of these in the chat function today. The second one is actually a reading list of a whole set of articles that have come out and op-ed pieces and all in the last month on the links between systemic racism and the environment. And this appeared in the New York Times. So again, I'll put that one in the chat function with the link. It's got a lot of links within the reading list, maybe 15, 20, maybe more articles and reports. And then finally, the House Select Committee on the Climate Crisis, headed by Kathy Castor from Florida, has come out with their staff report. It's over 500 pages, and it can give you some, I think, good clues about what could happen starting next year if we get a different administration after the November election. Kathy Castor was here doing a listening tour at Berkeley about a year ago. Some of us met with her. She was very tuned in, I thought, to many of the climate issues. And the report, while it focuses on emissions reduction, it has a good big section also of 40 or 50 pages on adaptation and resilience. So those 3 are in the or in the chat function for you. Good bedtime reading. So let me stop my sharing now and welcome again to everyone. And we're going to start with our presentations. James Eklund's going to be first. James is counsel at Squire, Patton and Boggs in Denver, large law firm. He was the director of the Colorado Water Conservation Board from 2013 to 2017, appointed by the governor, and the state's principal representative on the Colorado River, responsible for negotiation strategy with 6 states, Mexico, the federal agencies, and Congress. So welcome, James, and you can share your screen and you can start your talk.
Thank you, Bruce. Appreciate it. It's good to see new faces and familiar faces. Let me share my screen here.
Actually, I think I stopped. Good. I stopped mine, so yours should be fine.
Perfect. All right. Let's see here. Does that look okay, Bruce?
Yes.
Okay, great. So again, James Eklund. I'm currently with the law firm Squire Patton Boggs, which doesn't really have anything to do with this, but I am originally from the state of Colorado when I first made contact and was lucky enough to be looped into the efforts and the science and research community that you all form such a vital part of back when I was running the Colorado Water Conservation Board. I still am very engaged and active in trying to make sure that our water policy on specifically the Colorado River is consistent with all of the values that we have, and hopefully pays attention to science and is driven by science. So let me start saying you might be in the basin, you may not be. 1 second, sorry about that, Bruce. I had a window pop up I had to get rid of. Okay. So the Colorado River Basin is an area of focus for HyperFACETS. I think it predates even that work that you guys have been doing, and many of you have probably been working in the basin or have been aware of hydrologic data and analysis in the basin for a lot longer than I've been around. So I feel a little bit like I'm speaking to the luminaries here about something you all probably know very, very well. But I'm gonna make a run at telling you a story from the water management and policy standpoint. And hopefully it's illuminating to your research if you're doing research in the Colorado River or another basin where water stress is acute. I'm hoping that this gives you some food for thought, and feel free to follow up with any questions that you have. But the good, the bad, and the ugly is kind of how I think of the Colorado River. But these days it's all ugly, not in small part because of COVID, but we've got very limited ability to get out and walk around and look at head gates and go on the tours of the big reclamation facilities that govern the river right now, and that's a problem that we're trying to confront. A little context: this is the water stress tool that you probably all recognize that shows red where supply and demand are out of whack or projected to be out of whack. And the withdrawals in the Colorado River Basin are no exception, as you can see there. Colorado has a distinction of being at the headwaters of rivers that flow to 18 downstream states and Mexico. So it's kind of got an international feel to it as a basin that is somewhat unique. And it means that really other parts of the world, specifically Asia, the Middle East, Australia, growing parts of the EU have even focused on sending emissaries to the basin to ask questions about how we manage this system and kind of best practices. And it was my job at one point to try and make sure that we were doing the same thing. We were getting anything that we could learn from other efforts in other parts of the world. So the good, the bad, and the ugly of this thing really the bad part is climate change. We've seen these maps that I'm sure many of you study if you haven't researched the data on, but you just flip through these and you see a lot of record warmest temperature. Obviously, a lot of these focus on the Colorado River Basin. If you look at NASA's GRACE model, that it shows freshwater availability globally. It's a little dated, but it definitely shows the and in California in general. Drought maps here, I'll just flip through, show, again, a difficult situation that we face as a state, as a region, as a country, 40 million people and 7 states, 2 countries, about 270,000 square miles of territory in the basin. So it's a big basin. It's got a lot of agricultural heft to it. So economic realities of trade disputes and things like that really hit home in this basin. And if the basin can't produce in big agricultural producing regions, then it's felt the nationwide by our economy. Again, more GRACE mission maps that show the point. The Colorado River Basin, based on its average precipitation, shows more red and magenta type of dynamics, where you just don't have the water compared to a period of average that the Bureau of Reclamation uses to be, it's not headed in the right direction. I'll just put it that way. The last 20-year period of record has been the worst in human history, and probably, I think, I know Jim Prairie's been involved as a stakeholder, and he can tell you, how many years. I think it's like 1,200 years you got to go back in the paleohydrologic record to find a suite of years as bad as the one we've been experiencing for the last couple of decades now. It's led to, people applying the terms mega drought and aridification to the basin, and we just don't see any sign that that's going to abate as a reality. So at least not anytime soon. And so we're as water managers having to look at this basin as one unit, one system, and try and figure out increasingly where our commonalities of interest are and how we make management decisions with those. The 2 big buckets, if you want to think of them on this system, if you're not familiar with it, are Lake Powell and Lake Mead. Lake Powell being the upper basin's reservoir that sits right above that dark line that kind of bifurcates the basin. That's an artificial bifurcation there, a political boundary. It's nothing that you would see if you went to Leaf Area. There's no line there, but there is a USGS gauge, and it does show as in real time what the flow of the river is, and that's significant because the flow of the river cannot be depleted by the upper basin beyond 75 million acre feet in any 10-year period. So that means that if we drop below that, the lower basin would have a cause of action against us to have us essentially turn off water rights, turn off water consumption in the upper basin, and right the wrong that is articulated in the compact that was signed in 1922. I'll go back before 1922. These are my great-great-grandparents. They homesteaded on the north side of Grand Mesa in 1888. It's a cattle operation my folks still run today. And I can tell you that if you don't work in the Colorado River Basin, most everybody that touches the basin, you get infected with something akin to topophilia. The love of place, yeah, it permeates this basin. You've got the Grand Canyon, obviously, is a wonder of the world that most people identify with. But anybody that's been on the river or uses the river, if you're in Denver, and we'll get to that in a second, you use Colorado River water, and same if you're in LA and the Southern California region, certainly Phoenix and the metropolitan areas in Arizona, and even Salt Lake in Utah. We all drink, consume Colorado River molecules, or molecules that would have otherwise ended up there. And as a result, I think it's very important that to recognize that we all have a vested interest in this river, even if your roots might not go back as far as mine, or maybe they go back further. Again, we're talking about the 5th largest economy by GDP if you just took this basin as its own economic force. And just tying the river together, or the states together rather, you've got the Trans Mountain diversions that take water out of the basin and into the populated centers of the Front Range of Colorado. Then you've got the Colorado River Basin itself, or the Colorado River itself, that runs through the basin, and other diversions like the Metropolitan California Aqueduct that cut through Southern California and bring water to Southern California. And then if you want to just kind of complete the connection to the Bay Area, since I know that's where many of you are, you've got the State Water Project that connects. Hydrologically speaking, you're 4 steps away from Denver if you're in the Bay Area, because of the infrastructure that we've built. This is a map that's, I'm sure, no stranger to anybody on this call, that we're seeing more and more situations like this, instead of the kind of more cyclical, I would say, patterns that we built the reservoir systems to accommodate. We built Lake Powell and Lake Mead believing that the hydrology would function a certain way, and we built Havasu. I mean, all up and down the system, all that infrastructure was built predicated on a reality that is shaping up to be very markedly different than what we have, than what we had in the past. This is the basic law of the river. Its apportionment is 7.5 million acre feet to the upper basin, 7.5 million acre feet of consumptive use, mind you, to the lower basin. And then in 1944, we added 1.5 million acre feet for Mexico. And then, so if you total all that up, to make everybody happy, you're looking at 16.5 million acre feet. And we probably aren't having this brown bag because there's no issue. But there is, because back in the early 1900s, the 20-year period of record that really preceded the negotiated compact that I've been whining on and on about here, that was producing about 18 million acre feet on an annual basis in the system. And if you flash forward to the period of record that we're currently experiencing, you're closer to 12, maybe even south of that, in terms of annual yield of the river. So that means there's not enough for everybody to take everything that they would like, and not near enough to consume anyway. And so the dynamic on the river really necessitates astute science-based water management. And not to knock politics, but there is really a very limited amount that politically should be driving management decisions on the Colorado River. But I can tell you, a lot of politics is involved in the management process. So my hope is, I guess I'm skipping to the punchline here of the whole talk, but my hope is that you can take whatever data and analytics or studies that you are doing, the research that you're doing, and apply it to the Colorado River Basin in a way that informs the decision makers in the basin. I'm not saying that that is going to solve, the research you're doing isn't necessarily going to solve all the problems or answer all the questions on the river, specifically the political ones, but the information and the informed nature of the management system of the system is what is desperately needed. And I would just encourage you to look at that as you move forward with your work in HyperFACETS or elsewhere. This is the dynamic in Colorado. 80% of our precipitation's on the western side of the Continental Divide. 90% of our population is over on the eastern part of the Continental Divide of the state. And so we have about 25 big trans-mountain diversions that move water from the west to the east every year. That includes some of the stakeholders that you have on this effort of HyperFACETS. I know Lorna Katz and folks from Denver Water are involved, and they manage their system they've got a northern and a southern collection system that is in the Colorado River Basin, and really is very, very carefully watched, closely watched, and managed by Denver Water to supply water to their customers. This is just a little bit more of the ugly side of trying to get through the politics and the law and policy of water. This is just a map showing people served. I think it's by county, but most, if not all, of the counties in the western part of the country are at least balkanized by these boundaries, if not more. And that makes for very difficult, stratified, balkanized. It's got a really a complex web of stakeholders that drive decision making on the Colorado River and other western rivers. So when you see that kind of complexity, you might say, well, is the law and the policy, the management regime that focuses on how we distribute this water, who gets to use what and when, is it complex and convoluted? And the answer is yes. I'm just going to layer in all the Colorado River. This is the law of the river. These are the laws that came after the 1922 compact was signed, and they stand on the shoulders of that compact, going all the way up to a drought contingency plan that we executed with the lower basin states and the upper basin states and the Bureau of Reclamation working together on federal legislation to produce the management regime that is in effect until 2026. 2026 hits us, and we are supposed to have a new management regime in place that has been negotiated, and those negotiations are starting now, which really, again, not to just beat the dead horse here, but you're in a really good moment in terms of water science driving policy and management decisions to be working in this geographic area and on Colorado River issues in general, because the management discussions, the negotiations that are taking place right now amongst the states, the tribes, and the federal government, and Mexico for that matter, are all going to have to move forward. And if they move forward in the way that we've always done it, that's a massive mistake. I can just tell you that. We've played with the best, the best data that we've had at the time over the course of this basin's history to inform all this myriad of law that's on your screen. But we have not, in my opinion, gone far enough, fast enough, and strong enough in the direction of having our science inform our management decisions. Politics is the driver, and I hope that this negotiation going through 2026 represents an opportunity for us to start to change that. And I know the drought contingency plans, based on the excellent science that the Bureau of Reclamation has done and continues to do with people like Jim Prairie that run the river model, it is getting better. And the drought contingency plan negotiations were by far and away better than the 2007 negotiations, which were in turn better than the Colorado River Storage Project Act negotiations that took place back in the 50s and 60s. But it can always get better, and I think our trajectory is in the right direction, and I hope we don't have any backsliding on that trajectory, is I guess the point there. So this is a live feed, Bruce, from DC. I put this up here because it's to illustrate that we will not be getting bailed out of anything from DC, I don't think. Infrastructure bills are being discussed, but it sounds like gridlock. We're only a few precious months, even weeks and days away from an election and the election cycle that will take people out of DC to even work on anything, you know, as we get closer to the end of the month. So it's just to say that I really do think that the management decisions on this river are in the hands of the states and the tribes and the sovereigns that make it up. And I really hope that folks are able to kind of look at that dynamic and check your interests and your ability to participate in research that could help inform the next round of negotiations. Quick snapshot of where we are right now, because we have. Yeah, sorry. Go ahead.
Quick question before you move on. Do you know the previous slide, the train that collapses? Do you know where that was and when that was?
I'm pretty sure somebody told me it was in Oregon, and if you stop the clip, you can see on the coal car the you know, which railroad company it was. But you know, I put it up there as kind of being indicative of the current administration and our Congress, to be honest. So I don't know
Okay.
the exact location.
Thanks.
But Lake Mead's current level would be about 12 feet lower today had we not done the drought contingency planning. So if you're thinking, well, this is all abstract and it's kind of the management and the releases of these reservoirs between these reservoirs is kind of locked in and there's nothing really that can be done about those, think again. I'm here to dispel that. You're kind of in a period of time right now where decisions about when releases occur, how much those releases will be, what the trade-offs need to be among the states and the basins. Those are all decisions that are going to have to be made in the next coming, you know, couple of years, and there's no better time to be working in the space. I could go on and on about the reality of the drought contingency plans, but I'll just say this: in the upper basin, the drought contingency plans that, again, only occupy this window between really now and 2026, when we've got to have a new regime in place. That drought contingency plan allowed us to conserve water, allowed Arizona and California and Nevada to get away from the zero-sum game that they had been playing, where if they gave anything, then they would lose something. And it really allowed Arizona specifically to keep 162,000 acre feet of water in Lake Mead last year, above and beyond what they would have otherwise stored underground in the Phoenix, Tucson area. So that dynamic, it is real that you can make an impact here. The time is really ripe for good science and science-driven policy to be developed. And I just encourage you all to think about that as you move forward. In the Upper Basin, we have 2 tools that the drought contingency plan set up, and we're using one of them and we haven't used the other one because frankly, I don't think we can get out of our own way fast enough. But the first tool is managing the reservoirs that sit up above Lake Powell, pushing that water down to abate a crisis at Lake Powell. And then the second tool, though, that we have not used is a demand management program that is very similar, if not almost identical, to what the Lower Basin does in banking water in Lake Mead. We can conserve water in the Upper Basin and push it down to Lake Powell. We have not done so because we, as states, are trying to figure out what the programming would look like for those molecules of water to find their way down to Powell and be shepherded there and be accounted for there. If we can get that done, and frankly, it's overdue in my opinion that we should be populating that account now, especially given the current hydrology in the basin. We thought we had a good snowpack this year, and we did. Relatively speaking, this was a decent year should have been a decent year for Colorado snowmelt and runoff, and it has proven to be not the case. Our runoff numbers are way off where they should have been, and I suspect that people looking at the soil moisture content and the sponge kind of dynamic that it creates to soak up water would have something to say about that, and research that can be done there. Also, the big storm events that I know HyperFACETS has people looking at, the Miracle March type of events. Certainly, we cannot, as water managers, expect to, we can't rely on those for yield by in any way, shape, or form, but we can be more informed about what the impact is if we do see more of those events, and whether we see more of them, even if we can't pull out the crystal ball and tell you on what date certain you're going to see a cloudburst over Lake Dillon. I do still think that it is important for that research to be digestible and available to decision makers to be informed, even if they can't necessarily, write all of their policy based on it. So that's my pitch to the group. Bruce, I am happy to shut up and take any questions, or just turn it over to the next part of the program if you want.
Thank you very much, James. We're running a little behind, but we have time for one question. Bill, you had your hand up.
Yeah, and I don't think that James needs to answer this, but maybe send us information. I was just wondering, thinking about the plans to revise plans, what would be the most critical types of information on climate and climate change that we could provide? And I think it's probably something that'd be better if you just communicated with us afterwards.
Yeah, you bet.
Thank you. And thank you, James. If you could stop sharing your screen.
You bet.
And then we'll get Binod to start sharing his screen. So go ahead, Binod. So our second speaker for the day is Binod Pokharel. He's a postdoctoral fellow from Utah State University in the Plant, Soils, and Climate Department, which is in the College of Agriculture and Applied Sciences. Welcome, Binod, and the floor is yours.
Thank you, Bruce. Thank you very much, everyone, for being here. I would like to thank James for his nice outline and what are the legal issues and what's happening in Colorado River. That's really important. And I can connect that things in my presentation, I hope. So I will start. I have 2 components in my presentation today. One is how we can predict the Colorado water supply. not for the week or a month, but for years. And second part would be how the miracle spring that James briefly talked about can contribute for the water supply of Colorado River. So today's presentation is part of the decadal prediction of the Colorado water supply by Simon Wang and Yoshi Chikamoto. I'm not sure if he's here. Simon is not here because he's in Taiwan, so it's after midnight, so he cannot join today's meeting, but I invited Yoshi to join the meeting so that I don't need to take any difficult questions on the decadal prediction side, but we'll see. So I'll start with my presentation about the miracle. So when I start, what is the miracle spring? I try to search in the Google, and I found a lot of news. For example, like, let me. So for example, from 2015, so everybody knows that that is the part of miracles, because in May of 2015, we received a lot of precipitation over the basin, including many states, so that it was, everybody can claim that that was a miracle month. And however, there are other years that may be or may not be miracles. So including 1991, that is also the part of miracle year. And some of the news, I saw that there was a miracle in 2020 as well. And even I saw some news for 2016. So that means, so what is the basic definition of miracles? So how we can define the miracle? So unfortunately, I could not find single paper that talks about miracle spring. So that means we need to start from basic. So what is the definition? So this is where we want to relate and bring our stakeholders, because they are the real citizens. So they are dealing with the water in Colorado River basins and any other basin. So how we can define the miracles? What experience they got from their like past? Definitely the 2015 is miracle, but what other years they remember or they have recognized that it was also miracles. So that is the kind of things we want to do in this part of research that can be useful for the stakeholders. So starting from the Colorado River water supply, we can see that there is a very variation in year to year. And James also mentioned that there was a high yield year earlier in 20th century, but now the water supply is really small compared to the earlier years. So that means we cannot, if we see year to year variation, it's very difficult to predict. However, if we look some of the years, for example, 2015, we can see that there's comparatively more water supply in 2015. So that is also contributed by the miracle spring. So that means in some part of the years, not all these peaks are miracles, but some of the peaks are related to miracle spring precipitation. So that means that is the one thing I'll be talking in a little bit late in the following slides. But however, before that, I just want to mention one thing here. So we can see there is a year-to-year variation. However, if we smooth out this variation, we can see some kind of decadal pattern here. So if we look the water supply and the demand map from the Bureau of Reclamation, we can also see here. So 10-year moving average is kind of the pattern we can see in the water supply. So based on that one, Utah State scientists, including Simon Wang, they worked on how they can predict the Colorado water supply for a few months and also for a few years. So that means they developed the two different models. So the prediction system. One is the statistical. So that is the, this is the one statistical model that can predict for multi-year water supply. So that was published last year in Water Journal. So you can see that in this one, this is the observed water supply, so in the black line, and there are two lines indicating how the future water supply looks like. So that means this is based on the statistical model. So that statistical model can be used for the multi-year water prediction for the river. Another one, this is the one just, it is still under review. This is based on the model. So this is based on the climate model, and using the different ensembles members, they worked on the how the model data can be applied for the multi-year prediction. So in this graph, the blue curve is water supply, that's the observed data, and the red one is the model forecast. So from earlier around 1960s, we can see that the pattern is matching well here. So that means even if we have water supply data in 2019 or the 2018, so they use the model forecast and this predicted how the water supply looks like for coming to 1-2 years. So based on that one, we can see that there is some probability that there is a water deficiency in 2020. So this model can be used for the multi-year prediction. So this is the main result they have worked on so far. So this is one of the scientists from the Utah State, Yoshi Chikamoto, and also including the Simon Wang and other scientists here. So now I just want to move to the pattern. So that means we can see that in Colorado River Basin, we saw the both dry pattern and the wet pattern. So just looking at this peak and the deep line here, we can see that means there is some year water supply is great, some year is really low. So how we can define basically looking some indices. So first I look the PDSI and I use the observation data from 1895 to 2019. There is a 125 years data. So in this graph, I separated the upper basin and the lower basin. I hope I don't need to show the basin map since already James showed the detail about the basin. So we can see that here there are two, basically the four bar, but just focus on the red versus the blue one. So red means this is the upper basin, another one is the lower basin, but on the x-axis here, there are two parts. One is the drought and the no drought. So the solid bars shows that is from the 12 months water year data. So that means continuous from starting from October previous year to the September this year. So if there is a continuous drought over the basin, that is defined as a drought year, whole year drought. And if there is a no drought for the whole year, continuous 12 months, I define as a no drought year. So that means on the no drought year and the drought year, at least for the upper basin, we can see almost the same. The distribution is almost looks like same, around 35 years. 35 years continuous drought, 35 years continuous wet. If you look the lower basin, it's completely opposite. There are more than 45 years in drought, but there are less than around 20 years only at the wet period. And another hashed bars that shows only for the winter and spring. So these are seasonal. So I didn't consider other summer and the other period, but just the winter and spring, 6 months. So definitely it shows larger frequency, but the trend is same. When I found this result, I looked the year, some kind of year interval, starting from 1900. I grouped the data in 15 years interval, and I looked count the frequency here. So on the y-axis here is a number of years of the frequency. On the x-axis is a year interval. So if you look the two lines here, one is the dry, one is the wet. So blue one is the wet, red one is the dry. This is for the upper Colorado Basin. So we can see these two dry and the wet pattern, two patterns are moving in the opposite direction. So the dry is increasing, but the wet is decreasing. However, if you look the R square value for the wet pattern, decreasing R square is higher than the R square for the dry period. So that means dry is increasing, but not significant, but the wet is decreasing significantly. However, if you look the same pattern for the lower basin state, it's exactly opposite. It's the same in the same direction, but both are statistically significant for this last 120 years here. So dry is increasing, wet month is increasing. Another more important thing is I partition this data in 15 years interval. If you look the last 15 years, there is no single dry, continuous wet period. So that means it is not decreasing, but it is almost diminishing in the lower basin states. So this is the result. I found that between the dry and the wet period, how it is changing. Now, just want to look the third pattern, that is the miracle pattern. So miracle means winter is dry, but there is some precipitation event in the spring that diminishes the drought. So how that looks like. So how we can define the drought. For example, this is just a simple schematic I want to show. For example, we can use some drought indices of the precipitation on the y-axis here. So that means anything fall below 0 is dry, anything above 0 means wet. But on the x-axis, here is a month. So 0 is the miracle month, for example. It could be March, it could be May, or it could be April. So based on that one, if we make some kind of schematic, we want to see like this, yeah? So there is a dry, drought, and suddenly there is a wet. So that means due to some miracle precipitation, we can see that kind of pattern. So now, this is just the schematic. Can we see the same pattern based on some, if we utilize some kind of drought indices? So I looked the PDSI as a drought index, and I looked the pattern here. So based on the pattern, we can see that, yeah, we can see it. Yeah, it's PDSI on the y-axis, on the x-axis here is a month, 0 is the miracle month. So that means there was continuous drought for 70 months, and suddenly there is some precipitation during the spring, and we can see the wet period. So that means we see the same. So if you look at individual years here, we can see the same pattern, even though the intensity is different. So the drought intensity in some years is very high, and also the change from the drought to wet pattern is different. However, we can see the same pattern. So after that, we utilize different indices, not only the PDSI. What happens if we look the standardized precipitation index SPI, 1 month SPI, 24 months, and also the hydrological drought index. So including all those one, we can see can we see the similar pattern, for example, changing from the drought to the wet period. So then I look the different index here. For example, on the y-axis here, on the left side, there is a standardized precipitation index SPI. There are two SPI indices I use here. One is the SPI 01, another one is the SPI 24. On the right-hand side y-axis, there is a PDSI and the PSDI, or the hydrological index, hydrological drought index, and also just the Palmer drought severity index. So that means based on this one, the bar graph shows the SPI 1 month, and this blue solid line is the PDSI and the PSDI, and the dashed line is the SPI 24 month. So we can see the same pattern here. This is for the upper basin, and this is for the lower basin. So that means there is a continuous drought for at least 4 months, and we can suddenly see the wet. So that is 0 is the miracle month. However, if you look the SPI 24 and the PSDI, the response time is a little bit slower, because that is kind of what we expect, because for the hydrological drought, it will take some time. If there is a precipitation, we cannot see immediately there is an impact on hydrological drought. So it takes around 2 months period to see the positive hydrological drought index value. So this is how we are working on observational data, but still we need to define this, what is miracle, and after that, how we can use some kind of matrix. So I'm trying to develop a matrix that can be used to define the miracle. So based on that one, we want to see the similar pattern here, but can we use other indices? For example, SPI, 1 month, 3 months, 6 months, or the 24 months, or just the precipitation data. I try to use the precipitation data, but just looking the precipitation data, it is not possible to define the miracle. It's very noisy. But if we use these drought index, it is possible. So we want to get some more information from the stakeholders so that we can define the miracle in better way. Thank you.
Thank you, Binod. Questions? We have a couple of minutes. Questions for Binod on this interesting work. Just unmute yourself and fire away. Okay. Andy?
Well, yeah, Binod, I was actually wondering, so just to clarify with you, so you found these miracles based on time periods where you go from drought conditions into wet conditions.
Yes.
And one of the things that I've been curious about is, are those things correlated? Like, are the wet conditions equally likely and they just happen to follow a dry period, or is there actually something going on where you tend to get like dry periods followed by wet? Like, do you see what I'm saying? Or is there a statistical correlation?
Yes,
or
I think that is a great question,
events?
because I'm glad that I didn't mention and you asked that question, sorry. But one thing we can see that when there is a miracle, after the miracle, we can see that there is at least another 1 or 2 months continuous precipitation.
Mm-hmm.
So that means if there is a May miracle, only the May miracle cannot remove that drought. But if there is another precipitation event in June, that is definitely helpful. So we can see that the drought is not only for 1 month. So there is at least 3-4 months. So that means, yeah, there is a follow-up precipitation after that miracle.
Great. Another question for Binod?
It's Jim Prairie. I had one other question. Or at least maybe just a statement of something to look at. I think it'd be interesting to looking at how the frequency of these occurrences might be changing. I'm just kind of glancing, and is there some pattern to when these happen as well? And I know that's probably something you'll be exploring as you dive into this, but I think that would be interesting just to understand, is there a cycle to these as well? And if there is, can we kind of explore what's driving that cycle?
Thank you, Jim. Yeah, that's a great question, because I included the years here. How many years? So in Upper Basin, just based on my criteria so far, I found the 11 years out of 125 years, miracle spring cases. But Lower Basin, there are only 7 years. However, if you look the numbers here, there are kind of quite, there is some miracle in earlier period and also in the late, recent period. But the main question here is still, I defined here in 2009 and 2010 as a miracle here. Based on my matrix, I found that is a miracle. But is that true? How about the stakeholders? Do you see the 2009 and 2010 as also a miracle? So that is the kind of question. So we need to answer interacting with the stakeholders. But definitely that is another thing we will be looking, how that pattern has been changing from last 100 years or more than that, and how that will be changing in future climate. That is the main goal of this study. So,
great. Thank you, Binod. We are at noon. Want to thank Binod and James both for your very interesting presentations. We will put them on the website. I'll talk with Andy about that. And I will also send out a follow-up email with the links that were in the chat function here. Our next brown bag number 3 will be back to the usual schedule of the first Thursday. So that'll be the 6th of August. And we look forward to seeing all of you then. And thank you for giving us your time today. Andy, final comments?
Nope, just thanks everyone. I have actually had another sciencey question, but we don't really have time for that, and I have another meetings to run to, so maybe I'll send it by email. But yeah, this went really well. Thank you, everyone. These were both great presentations.
Thank you, everyone.
Thanks, everyone.
Thank you very much.
Have a good Thursday.
Very good. Bye-bye.
Bye.